Here's just a quick video about the different special right triangles that we're going to be using in the unit. Remember, this unit is called the unit circle because we're talking about the circle with a radius of 1. So this point out here would be 1, 0. This point up here is 0, 1. And likewise it comes back negative 1, 0. Now, you might be thinking, hey, we're talking about a circle. Why are we using triangles? Well, it just so happens that if you pick a point on this circle and we want to know what point that is on the unit circle, to get to that point, you start at the origin and you always go over the x value and you go up that y value. So, it kind of turns into this right triangle. Now, okay, so like with this one being our x and then how much you go up being your y. So, depending on the angle measure that we go up, we can use some trig functions. And with other videos, you know that the cosine of your theta will be your x. You know the sine of your theta or your angle measure will be y, because our hypotenuse is 1. No matter where we draw this angle, rewind if you want to go see that other stuff. No matter where we draw this angle, reference angle, things like that, the hypotenuse is still 1. So our x value is going to be the cosine of it. Our y value is going to be the sine of it. Granted, we are only going to talk about 3 special right triangles, and 10's not one of them. We're going to talk about 30-degree triangles, we're going to talk about 60-degree triangles, and we're going to talk about 45-degree triangles. So, looking ahead to this first one, what we did as kind of an exploration for this unit, we took an equilateral triangle of side length 1. Wow, that yellow does not show up very well. We split it in half, and I asked the question, how high is it? And kind of an activity that we did together in class, we're like, well, if the side is 1 and we cut this side in half, that's just a half. And then with a little bit of the Pythagorean theorem, we know, or we can solve for the height. So then subtract the 1/4 is 3/4. Take the square root of both sides, and just kind of some facts about square roots. You take the square root of the top and the square root of the bottom. So our height is square root of 3/2. Now that gives us one of our special right triangles right off the bat. So again, with a little bit of Pythagorean theorem, the hypotenuse is 1 was the kicker. This side was a half. We solved for this side to be square root of 3/2. And I forgot to mention that on an equilateral triangle, this angle is 60 degrees. And we drop that down. Up here, half of 60 would have been 30. So this is a 60-degree triangle. Keeping in mind, let's just turn that on its side. If I would just turn it, the 30-degree angle is very similar. Again, the short side is going to be a half. The long side is going to be square root of 3/2. And that gives us some information for how we are going to figure out all these different points on the unit circle without necessarily knowing all those values. So if this is a 30-degree angle, we know what this point is up here based on your y and your x. So the 30-degree angle, this is your x, this is your y. So it looks like I went over square root of 3/2, and I went up a half. We're going to get into more details about cosine and sine and all that, but that's for the 30 and the 60. And then the last one is 45. So the last one, we have an isosceles triangle, an isosceles right triangle. So we know the two sides are the same, so the two angles are the same, so we know it's 45 degrees. And we're going to call both of these sides 1. And again, what we're going to do is figure out what the height is of this triangle. Now, if this side is 1 and this side is 1, we can figure out what the length of this whole side is, again using the Pythagorean theorem. A squared plus b squared equals c squared. 1 plus 1 is 2. So this long side is the square root of 2. But if I split this triangle in half, and I only care about this part. This little part is square root of 2 over 2. Now again, we could use a really fancy Pythagorean theorem and do a squared plus h squared is that, but if this is a 45-degree angle and this I drop straight down, I know this is a 45-degree angle, so I know my two sides are the same. If I just take that off of that big hot mess up there and I just draw my own little triangle down here, if we have a right triangle with a 45-degree measure and a hypotenuse of 1, but we know it's always going to be a hypotenuse of 1 because we're dealing with the unit circle. So my two sides are square root of 2 over 2, square root of 2 over 2. Again, that would be helpful if I'm asking you for the point on the circle at, say, 135 degrees. 135 degrees is over there. That would give me a 45-degree reference angle. And then I just know my x value went back square root of 2 over 2, and I went up square root of 2 over 2, and that would give me this point on the unit circle. Again, we're going to use these unit circles and these special right triangles throughout the duration of this whole unit, but this is just kind of showing you how we derived that information.